So hello everyone, welcome to BitbyBit by Ishat Kumar Jha, and today we would be discussing the solutions of Code Forces Round 898 Div 4 from question A to question E. Okay, so our first question is short. So there are three cards with letter A, B, C placed in a row in some order. You can do the following operation at most once. Pick two cards and swap them. Is it possible that the row becomes ABC after the operation? Output yes or no, according like if it is possible or not. So let's first see what the question is all about. So first it says it gives me three characters. Let's say A, B, C in any order, any random order. It could be C, B, A, or it could be A, C, B, something like that. Okay. Now, first thing that I know that I can do with this is swap any two characters. I can swap any two characters, and this operation can be done at most once. So either I do it once or either I don't do it. Okay. So next thing that I can infer from this is that what all operation can I make? It's that I swap zero and first character, or I swap the first and second character, or I swap zero and first character. Sorry, or I swap. Wait. So zero and first and second, and zero and second. These three swap operations can only be made. Okay, only three swap operations are possible. So now, how can we do it? Yeah. So there could be multiple ways to code it. Like I think so. This is a straightforward implementation that one can do. Now, to do this, what can be our approach? One approach that I can tell you, which even I used. So first approach could be you create, one is your original string, then you create one more string, which is so I take a string s, then I create another string s1, which is equal to s, and I have s2, which is equal to s, and then I have s3, which is equal to s. Now in s1, I swap the element at 0th index and the first index. In S2, I swap the first index and the second index, and in S3, I swap out the 0th and the second. Now, if S, S1, S2, or S3, I have a string, I can even have a string target, which could be equal to A, B, C. Yeah. And if any of them out of these four strings, any of them is equal to a target, then I know it's yes, otherwise the answer is no. Quite simple approach. Another approach that can be done, like which I didn't implement at that time, is something like this. So you have a string s, again you take the input, and you have the string target. Target is again that ABC string. Yeah. So that ABC string, we got that. Now string s is the original string. We take the input. Okay, I take the input of string s. Then what I can do is I first swap 0 and the first. So I perform a swap operation on 0, comma 1. Or let's say before performing this swap operation, oh sorry. So I have this string s. First I have string target, which is equal to ABC. Then I have string s. I've taken the input of string s. Then I check if s is equal to our target string, then I print yes. Okay. Otherwise, I first swap the 0 and the first characters. So now if now s is equal to target, then I could again print, like I could print yes. So If this is yes, I can return. Like I don't want to print yes again and again. Okay. Here also I can return simply. Now, next I perform the swap operation on 0 and 1 again. Because if the string is not equal to target even after performing the swap, I have to reverse it. Like I need to make the string as the original one. So, and now I would perform the swap 1 comma 2. So I perform swap 1 comma 2. I again check, like if s is equal to target, then yes and return. If not, then again I reverse the string to its original position by swapping it, and then I get swap 0 comma 2. Now again, if this is equal to target, then I print yes and then I return. But if still it's not uh, equal to the target, then we can't do anything. So we do no. Let's see my implementation. I could show you the implementation. Just wait a second. Yes, so it's false. Okay. I see. This is my target string ABC. This is my string S. So this is my string S. I took the input. I have this string 1. I have swapped in 1. I have swapped the 0 and first index. Then string 2, first and the second index. String 3, I have swapped the 0 and the second index. And then I've compared all 4 strings from my target string, which is ABC. If any of them is equal to, um, if any of them is equal to the target string, then I print yes, otherwise I print no. Now let's talk about question number 2. I think so the overall contest was quite good today. Not too hard, not too low. Slavic is preparing a present for a friend's birthday. He has an array A of n digits, and the present will be product of all these digits. Because Slavic is a good kid, he wants to make the biggest product possible. He wants to add 1 exactly to one of his digits. What is the maximum product Slavic can make? Very easy question, I think so. Maximum product questions we have seen quite a lot of times. So, um, you would read the problem first if you want. You could. Sorry. So you read the problem. Okay. So I would explain you the problem with the help of a test case. It's better. So I have n digits which are 4 in this, and they are 2, 2, 1, 2. Current product. It's 2 to 4, 4, 1, 5. Sorry, 2 into 2, 4, 4 into 1, 4. It's it. Yeah. What can he do? What is operation possible? So one operation that he can do is he can add 1 to any of its element. Add 1 to any element. Okay, that's the thing. Add 1 to any element, and this could be done only once. Now, first of all, our first edge case is whenever we have a zero, sorry, whenever we have a zero in our array. So let's say our array has 2 0. I can add, like, it's an 0 comma 0 comma 2 3 4. What's the maximum possible product here? It's 0, because I can increase only one element. So if I increase any of these zeros, one would remain as 0 only, and hence the total product would be 0 only. So if we have zeros greater than or equal to 2, then the answer is 0. If we have 1 0, then what is the answer? So if we have 1 0, let's say the case is 0 1 3 5 6. Now here what is the answer? I would always do, in this case I would get 0. Even if I increase any of the elements, I can never get a product larger than 0. So I have to increase 0. And this 0 would become what? This 0 would become 1. So this 0 becomes 1. What is the product? 1 into 1, and then 3, 5, 15, 15, 6, 19. Okay. The last case, where we don't have any 0. So we always increase the smallest number the smallest number. When cheatiness could be here, like you could have used the test cases to derive your answer, which number to increase, and in every test case we are increasing the smallest number. So here also in these kind of test cases also we are increasing, always increasing the smallest number. So we can even make a generalized code, although I made a separated. Okay, so let's see the smallest number here. So we always increase the smallest number. Why? So let's say I have 4, 1, 2, 3. Now why do I always increase 1? If even if I increase it 5, 5 into 1 is 5. And if I have 4 into 2, it's 8. It's always noticed that when we increase the smaller number, it gives a larger product. A larger product. So this kind of greedy proof that you can search of. Let's see the implementation. This code, I think so. I have made a bit weird implementation for this question, but still no problem. So you see, I have got the vector in, and then I've taken the inputs. Just don't get confused by it. Now ch, this is a count function which counts the number of, like, frequency of basically the R digits. The wall means just v dot begin comma v dot end. So I have this ch as the count of zeros. So if ch is greater than 1, that is it's 2, 3, then the answer is always 0. If ch is 1 or ch is 0, so I made these two cases generalized. So it's better that I explain this part because this is quite, mm, weird in my implementation. So let me explain the approach to you. So for this question, so you have quite understood, like I think so you have understood this to more than 2 0 part. If 1 0, what we can do? We can always sort the whole array, sort the array, then increase the element at first index by 1, calculate the product, calculate the product and print your answer. Quite easy, no rocket science. Okay, so we are done with one more question. Let's check out for the third question. I think the third question was a bit interesting for all of us. If you want to see the solution, you could just have a look. So this is my else if. I would explain. Answer is 1. So I've sorted it in decreasing order. I don't know what was I doing that time. So I've taken a for loop. If v of I is 0, then I continue. Otherwise, I multiply. I calculate the product. And if there is no 0, then what I do with the smallest number, I divide and I increase the smallest number and then I multiply. So that's like the same thing that we were doing. Okay, now let's check out for the C question. Okay, now see, this is quite an interesting question. So something noticeable is there. Let's construct the matrix first. It's a 10 cross 10 matrix. So it's 1. Okay, 10. And then 1, 2, 3, 4, then 5, then 6, then 7, then 8. So it's quite easily done. That's okay. Okay. This is a 10 cross 10 matrix. Let's color all the 1, like wherever I get 1, with red color. So I just draw a line. It's better for me and for you so that we don't waste time. Now, wherever I get 2, I color it with blue. Wherever I get 3, I color it with yellow. Oh, sorry. Thinks I did something wrong. Yeah, so it should be from here. I think I messed it all up. Wait, let's do one thing. Let's follow an easy way. Copy this image and I just paste it. Oh, sorry. Oh, sorry. Sorry. So I just paste it in this paste. Yeah. Now this is quite nice, quite understandable for you all also. Yeah. So now you observe one thing. If I write the row number and column number, row number 0, 1, 2, 3, 4, 5, 6, 7, uh, yeah, 8, 9. And here if I write the column number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now interesting fact. Easiest code. You see, if your, let's name this row, this column. If your row is 0, whole line, you get 1 point. Or I use this double, lines, double vertical lines for or. If your row is 9, that is n minus 1. So if your r is 9, then also this 9, this part. Then also you get 1 point only. Or if your column is 0, like this, if your column is 0, then also you get 1 point. And if your column is 9, then also you get 1 point. So if this statement is true, then you can increment your point with 1. Okay. And else if. So we write else if in C++, in Python we write elif. So you could write as per your syntax. If my row is 1, okay, or my row is, sorry, this I marked the column. So if my row is 1 or my row is 8, so like I write here or my row is 8 or my row is, or my column is 1 or my column is 8 or column is 1 or column is 8, then I get 2 points. Similarly, we increase it every time. Like we increase the lower number with 1 and decrease the larger number with, decrease the larger number with 1. So now points plus is equals to 2. Now for the next points, 3 points, we would write r is equals to 2 or r is equals to 7. So this is quite observation based. If you have this image, try thinking of the logic hole. I would show you the solution to that. Okay, so the solution is quite, I think, so clear. I have the answer variable. I've taken the input first of all. I have the answer variable and I put it in into 10 loop. So now, if this is x, like if I have some good thing there on a row, if I have a dart there, then what I would do is I would check for the row and column number, and accordingly I would be increasing the answer. You can check the conditions. Let's move on to question number 4. That is the D question. Okay, this was a very easy question literally. So you're given a strip of paper as that is n cells long. Each cell is either black or white. In one operation, you can take any k consecutive cells and make them all white. Find the minimum number of operations needed to remove all black cells. So you can see the problem tag, that's greedy implementation. Let's understand the question first. Okay, so the question says I have a string S of length n. Okay, what I can do is if I look, so I have some white cells, some black cells. I need to color all black cells to white, and for that what we can do, I take I have to take for that the operation is k consecutive cells and color them on white. So if you think of a greedy approach, let's take it well for example. 6, comma 3, 6, comma 3, N and K. N and K. Then I have WB, WWWB. Okay. So I have WB, WWWB. You see, I have three. Matlab, I can only increase, like, I can only convert any three elements. So, like, I can convert only these three into white. So, what is the greedy approach behind this? If you think for a while, it's like a cool mind, you would always see then whenever I reach a black, first black, then it's always better that I utilize all the key elements. Because if I don't utilize, if maybe there is one more black, if I don't utilize, then I have to make one more operation for this. Yeah, I have to make one more operation for this black. So that's why it's always better to utilize all three. So I skip these two because even if there's a black, it would get converted. So jump, I jump, I jump K, sorry, I jump K cells. So in this here, and then this the last, so B and B. So I have two. Now let's take another case that is maybe this WWBWB. Um, WWBWB. Let's say it's 5 and 3. So now here, or maybe WW. So it's 8. You see it? It's 8. I go here, I go here, I don't find any black. I go here, I find a black. And then I have to convert it to white. So I take all the three elements. I've done my first operation. Then I go here, here. So I have done my second operation. So the answer is 2 only. So the code is very simple for this question, I think. So the easiest code of the whole, whole honest. So you get N and K, you get a string S, you get a count variable. Now if this is B, I increment my count that like I have performed one operation to change black to white, and then I skip K steps. Basically K minus 1 is done because after it will get out of this if condition, it would again get plus incremented by 1. So that would be basically sorry, yeah, that would be I plus is equals to K minus 1 and then I plus plus. So this would be something. So it would be I plus is equals to K minus 1 plus 1. This would get cancelled. So I plus is equals to K. Okay, quite easy, quite simple. Now the last question that I was able to do in this contest was question number E. This was a very good, binary search problem. So a bit, difficult to think maybe. That is binary search. It was solely binary search. And now the explanation of this is quite, when do you apply binary search? That's the most important question. When do you apply binary search? So binary search is basically applied when you have two fixed ranges. So I knew my answer could be between 1 and something around 1e9, 2e9, something like that. When I have these two fixed ranges, no, I've like my answer is between them, but they are very large to compute that I can compute them. Then you should always think of binary search, DP, some kind of that thing. And if you're able to implement a good code, then solve it. So if you read the question, I would ask you to read the question on your own because sometimes reading a question on your own is very helpful. Otherwise, I would be explaining right now. So let's just snip the question. Is paste. Okay, so the question is pasted. I just decrease the size. That's it. Okay. Read the question. You love fish. Okay, so that's why you decided to build an aquarium. You have piece of coral made of n columns. N columns like this. So n piece of corals, and every piece of coral is A of I union. So here, how many pieces? One, 2, 3, 4, 5, 6, 7. So our n is equal to 7, and these are the heights. I am given a number W. Okay, I am given a number W. No, not a W actually. I am given something known as X. I am given something known as X. And that is the most amount of water that I can use. Most amount of water. Of So how is water being used? So let's say I have chosen a wall height of 4 out here. Okay, 4 out here. So if the height is less than 4, then the difference between the height and the coral height is the amount of water I use. Explaining in simpler terms, if I have this one and I choose this wall height of the aquarium as 4, then I use 3 units of water. Simple, easy, clear. Here it is written something like that. Okay. Now, how would you select? You need to have the maximum height possible, and you need to use not more than X units of water. How can you do that? Now, let's see the example cases. Let's snip out them. Okay, snip them out. Okay, let's see the cases. Open board, paste. I- This kind of questions, no, help your brain to basically work in pressures. This was not a very easy question to think of, and I took much time while thinking of. Think that I'm a pro coder. So you see, now here, second line of each test case. So this is the input format. This is my first n. This is my x, and these are my height. First example has been, explained in the statement. Now the second example, let's see. 3, 10, 1, comma 1, comma 1. I can use 10 units of water. I have 3 and 1, comma 1, comma 1. What is the wall height? I will choose 4. Why? Let's see. This is 1. This is 1. This is 1. I can utilize 10 water. Theory of. So, I'm thinking it. Basically, we are thinking it as like our lowest could be 1, because we can't use 1 lower than 1 height. And our highest, how do we determine the highest? Take a case, if you have only a single element 1 and you have 1e9 as your x, then you can have the wall height as 1e9 plus 1. So for safer side, you could use 2e9, approximately something like that, bit big, so that you know, you at least go till 1e9 plus 1 when you are doing your binary search. How to implement the binary search? Let's see the code. So because of the range, I think so I did in the first question test, like first submission, I did 1e9 plus 2. Yeah, it was 1e9 plus 2. That's why I got a bit wrong answer on test 3, because you know what happens in 1e9 plus 2 is, see, the answer could go till 2e9 also, because this is 1000, 1e9, and this is 1e9 again. So I could use 29. So 1e9 plus 1e9, so it's 2e9. That's good. So that's why we should at least use 1e9. Although I used 1e13, because log n, it doesn't matter. Even if you use 2 to the power 60, it doesn't matter, because it would be log 2 of 60. So only 60 operation will be used. While low is less than high, are mid function, then sum. Now the sum that I told the difference between the wall height and the height of the corals. If sum is k, simply see out your answer, return. If sum is less than k, then you can store the answer as max, like which of these is max. So you always want the greatest height, so you store the max, and then you can store this is a normal binary search function. You can even read the tutorial how it works. So then you create low to mid plus one, and then and if the sum is greater than k, then you have high is equals to mid, and then you see out your answer. This was the easy code that of binary set. So this was all about the contest. Although I tried doing the G question, but I was not able to do it. Okay, so I hope you like the video. Thank you.